Okay, so tonight we're going to talk about proportional versus non-proportional. I'm getting lost in my spelling there. Proportional versus non-proportional relationships. There we go. So we got to talk about what is proportional and what is non-proportional. So I think I'm going to type this out for you because it'll be a lot neater than me writing it. So two quantities are proportional if they have a constant ratio or unit rate. And I'll explain what that means in a second. But they are proportional if they have a constant ratio or a constant unit rate. If the ratio is not constant, if it's not constant, then I spelled constant wrong. There we go. Then the two quantities are non-proportional. Oh, it doesn't like that. Are non-proportional. Okay. So, we're going to look at what that means. So what that means is this. And let's take a look at an example problem. Oops, didn't want to do that. Wanted to do this. Just separate a line there. There we go. So let's write an example here. Andrew earns $18 per hour for mowing lawns. So Andrew earns $18 an hour per hour for mowing lawns. Is the amount he earns proportional to the number of hours he spends mowing? So what we're going to do is we're going to set up a chart. And the chart's going to look like this. We're going to say, is the amount he earns, so the amount of money he earns, we want it as a proportional to the number of hours that he actually mows. So let's think about this for a second. If he mows the lawn for 1 hour, how much will he earn? Well, he earns $18. Okay? If he mows for 2 hours, how much money will he earn? Well, he'll earn 18 and 18, which is 36. If he has 3 hours, he earns $54. And let's do one more. 4 hours, he would actually earn $72. Now, we need to look at it to see if they're proportional. If they're proportional, they will have the same unit rate. So for each one of these, I push this up. Oh, no, I can't do that. All right, never mind. So for each one of these, so for here, 18 over 1, that's the unit rate. 18 over 1 is 18. Here, for the 36 over 2, 36 over 2 is the rate. The unit rate is 18. For this one, I have the rate is $54 for 3 hours. The unit rate is 18. And finally, I get $72 for 4 hours, which gives me a unit rate of 18, because 72 divided by 4 is 18. So since each one of those ratios, 18 to 1, 36 to 2, 54 to 3, and 72 to 4, all come out to be 18, then yes, this is proportional. Now, let's take a look at this problem. And I am actually going to pause the recording while I type this. So the next thing you see will be a question popping up. Okay, so here's the question. Uptown Tickets charges $7 per baseball game ticket plus $3 processing fee per order. So it's $7 per ticket, and then it's an additional $3 for the entire order. Is the cost of an order proportional to the number of tickets ordered? So let's take a look at a chart. I'm looking at the amount of money I'm spending and the number of tickets that I'm ordering. If I order one ticket, how much will it cost me? Well, it's going to be $7 for the ticket plus the $3 for the ordering of the ticket. So it's going to cost me a total of $10. If I order 2 tickets, let's see, 2 tickets is going to be $7 for the first ticket, $7 for the second ticket, so that's $14, plus $3, so that's going to be $17. If I order 3 tickets, how much will it cost me? Pause the recording if you need to figure it out. But yes, absolutely, it will cost me $24 because it's 7 tickets at $3, 3 tickets at $7 each, which is $21 plus the $3 processing fee. And let's just do one more just to do it. If I order 4 tickets, it'll cost me what? Good. 4 tickets at $7 is $28, plus $3 more is $31. Now let's check out the proportions. This here is a 10 to 1 ratio, which is 10. This is a 17 to 2 ratio, which is 8.5. Uh-oh. Since the unit rates are not the same, one is 10, one is 8.5, then this is not proportional. Or we'll say non-proportional because the unit rates are not the same. Okay, so here I've given you 2 charts, Emilio and Walter. And these charts represent, well, it doesn't matter what they represent. Oh, the time spent typing and the number of words they type. So the time is how much time they spend typing, and the top number is the number of words that they type. And I want to know which one of these charts represents a proportional relationship. Which one represents a proportional relationships? So if we look at the first one, this is 20 to 30, or 2/3. This one is 40 to 60, which is 2/3. This is 60 to 90, which is also 2/3. When I look at Walter's, I get 25 to 30, which is 5/6. Here I get 60 to 60, which is 1, and this is 80 to 90, which is 8/9. Well, obviously, since these are all the same, and these are not all the same, it turns out that Emilio's chart is the proportional chart. So Emilio's is proportional where Walter's is not. What I would like you to do is I would like you in your book to go to page 36, and I want you to do problems number 1 and 2. Now, there's an extra bonus on here. Not only do I want you to do these problems for practice, and we'll go over them tomorrow, but I also want you, in the comment section of the video, I want you to put your first name, your last initial, and then I want you to tell me for problem number 2, I want you to tell me whose situation represents a proportional relationship. Just write the name of the person. Who, so I want to know who is proportional. And you just have to do the name of the person. Enter that in there, and we're going to look at how what people said tomorrow. All right. Have a good night, and we'll see you the next time in class.